You know what I really like about this video thing? You guys don't know much about me. I mean, granted that seems really shallow, but I mean more in the physical. Like, you guys totally don't know if I'm wearing pants. Rest assured, I totally am. But today I want to talk to you about SOHCAHTOA. Whoa, that's a funny name. It kind of sounds like Krakatoa or something like it. Whenever I hear SOHCAHTOA, I imagine this big fat like Indian guy from like Honolulu that's got all that bling right in here, and he's going SOHCAHTOA, something like that. Actually, it's a whole lot less exciting. It's about algebra. Go figure. That's why I'm here. Now, I'm not going to explain a lot about previous. It's about triangles, and if you don't know much about triangles, go back and watch my other video. I don't want to repeat myself. That's boring. So I've got SOHCAHTOA spelt here on the screen. Now, what this actually means is it's a way to find the side lengths of a triangle based off of the measurements of the angles. Doesn't that absolutely blow your mind? Now, what the S, the C, and the T stand for, why they're bigger, is sine, cosine, and tangent. Now, on your calculator, most calculators have this, except it doesn't spell it sine, cosine, or tangent. It's sin, cos, cos, or tan. I always thought tan was funny because I'm not going to use the color tan in math. Now, what this means, SOHCAHTOA is a little way of remembering what each one stands for. Sine, or sin, means opposite over hypotenuse. I'll explain it, don't worry. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. This seems extremely confusing, doesn't it? Yes, well, that's your answer, is yes. I don't care. Now, let's go over a couple little things about a right triangle, because this is what sine, cosine, and tangent deal with, is a right triangle. Now, let's say we have angle theta, A, B, and C. We want to find, say, the sine of angle theta. Now, you're just going to use your opposite. Now, opposite is the side that is the farthest away from the angle. So for theta, the opposite is going to be A. Now, we're going to put the opposite over the hypotenuse. The hypotenuse is always the longest side. The longest side is always going to be opposite the right angle. So C is our longest side. It's opposite the right angle, and it's the longest side, so it's the hypotenuse. So let's say sine of theta equals A over C. As you can tell, cosine is going to be adjacent over hypotenuse. Adjacent is the side that's closest, and it's not the hypotenuse, but it's still touching the angle. So adjacent has to be B. Cosine of theta equals B over C, because we've got it over the hypotenuse. Now, let's go a bit more involved. This is my really cool triangle. I've even got a Greek letter that I don't even know. This one. They show it a lot in your book. It looks a little bit more like an X. I can't draw it that well. Let's take, for example, tangent of theta. Now, TOA, tangent, opposite, adjacent. So we're going to have the opposite, A, over adjacent, B, because opposite, adjacent, with a T in front of it is TOA. Okay? Makes sense. Now, let me throw a curveball at you. Sign of the funny letter. I think it's an AX. It might be alpha. Don't quote me on that. Definitely don't quote me on that. I think that's wrong. Now, sine of X, if you repeat the SOHCAHTOA, so is sine, opposite, so, and then hypotenuse. So we have the opposite over the hypotenuse. Now, the opposite is no longer A, since we're dealing with this other corner, this other angle. So now the opposite is B. You have B over C, because the hypotenuse always remains the same. no matter what. Now, when will we ever use this in our calculators? Because we've got sine, cosine, and tangent on our calculators. That seems a little bit ridiculous and incredibly snooty of you. Gosh, I can't believe you would ask me with that kind of an attitude. But oh well. Now let's make this 60 degrees. I'll explain all of that, because I'm just that nice of a guy. Even when you guys are jerks to me, I will explain it. Now, last video, we went over the special triangle to 30, 60, 90. 1, square root 3, and 2. Weird triangle, I know, but I want to go over a couple things. Let's do the sine of 30. Now, the sine of 30, what you're going to do is, because of SOL, you have opposite over hypotenuse. So you're going to have 1 over 2. Now the interesting thing is this is the ratio that we're going to use. This is how we were shown to do it and such. Now if you plug into your calculator sine of 30, you're going to get 0.5. And why 0.5? Because sine of 30 equals 1 over 2. Now let's say we take cosine of 60. Now, because of the SOHCAHTOA, that's what we're going over, cosine. Now we want to go over adjacent over hypotenuse. We're going to get the same answer. And once again, if you plug this into your calculator, cosine of 60, you're going to get 0.5. Now, why do we need to know this if we can just figure it out, right? That seems ridiculously stupid. I want to go over the algebraic perspective of these. This is where it starts to suck. Let's say we have sine. No, I've done sine and cosine already. Let's do tangent. So we have the color tan, not really. And let's say we have 53.1. And that equals x over 6. Now, in a picture, what we would be doing, this, and let's say 53.1, that's our angle that we have and we know. Now, TOA, because we're using tangent, is opposite over adjacent. So we're trying to figure out this length. This is where sine, cosine, and tangent all come into play. We only have two angles and one length, yet we can still figure out all the lengths of this. But right now, let's just stick to finding the length of x. How we're going to do this is just like algebra. So we have x divided by 6. You just multiply 6 on each side. So you have 6 tangent of 53.1 equals x. Now you can just plug this into your calculator. Plug and chug. Now, if you plug this into your calculator, you're going to get roughly 8. It's pretty darn close, so we'll just round. 6 tangent of 53.1 equals about 8. Now, this is where you're going to be using sine, cosine, and tangent the most, is algebraically, to figure out the length of a side. Now, let's say we have an x in the denominator instead of a numerator. Let's go with cosine of 37 equals, and let's do 12 over x. Now, I'm going to show you guys a quick little cheat. I don't know how I figured this out or how anybody did, but I learned it from Hempel, and I want to show you guys real quick. See how this is funny? You can't like divide it or multiply it or anything. All you have to do is drag this whole 12 and its line over cosine of 37. So you get 12, oh, ooh, wow, that's awful. 12 over cosine 37 equals x. Now if you plug this into your calculator, you're going to get an answer, and that's going to be pretty close to 15. But I just want to show you how to be able to do this math. Now, lastly, what happens if we have an x right after our sine, cosine, or tangent? This is where it's going to become really interesting. It's going to be your inverse. Now, what does the inverse mean? What do we do? I'm going to show you. The inverse is the opposite of SOHCAHTOA. It's not quite the opposite, but what it does is the opposite. The inverse is the way to find the angle from two sides. So, an example triangle would be much like this. Say we have theta, 6, and 11. So we have the adjacent, and we have the hypotenuse. We have a. So what do we need to use? We need to use cosine. So we have SOHCAHTOA. This way we have cosine, and because we know the adjacent and the opposite sides, we want to figure out this angle. So we would have, cosine of theta equals 6 over 11. Now, undoing a cosine, a sine, or a tangent is exactly like undoing multiplication or division, or an addition, subtraction. You take the opposite. Well, for a cosine or a sine or a tangent, we have an inverse, which is the same thing. All it is it's written like this. This is inverse cosine. Now, if you were to inverse cosine a cosine, they cancel out. But remember, algebraically, if you do it to one side, you have to do it to the other. So we end up with theta equals inverse cosine. So we have this tiny little 1 over it. And then we take the inverse cosine of 6 over 11. Now you're going to have to plug this into your calculator, and if you don't know how, I'm not going to waste my time explaining it to you. Go and ask Mr. Hemphill. He knows how to do it. And if not, he'll find out how. Now, once you plug this into your calculator, you're going to be able to come up with an answer for theta. And so for this example, your angle is going to end up being about 56.9 degrees. So, oops, didn't mean to do that. Theta equals roughly 56.9 degrees. Now, if there's anything else you need, I know we just kind of barely skimmed the top of inverses. But if there is anything else you need or any other help, you can definitely go to Mr. Hemphill or rewatch the video. But I highly recommend you rewind the video right now and you go back and you write down SOHCAHTOA. Either that or just like scream it out in the middle of your test, like SOHCAHTOA. Then you'll remember, and you'll remember that for the rest of your life. Everybody else in your class will too. That'll be a Facebook post that goes viral. Anyway, if you do need anything to be helped with, feel free to ask anybody who can. Until next time.